Hello, my dear children. Welcome to the mathematics class. Today, we are going to discuss trigonometric functions. Exercise 3.2. Exercise 3.2. Page number 63. Question number 6. Okay, my dear children. Are you ready to listen the class? Right. See the question. Find the value of sine 765 degrees. We have to find sine 765 degrees value. Understood this question, my dear children? We know sine 0 degrees, sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees, sine 180 degrees, and we have written that table. We have learned. I hope you have learnt well that values. You have memorized well. Isn't it, my children? Right. But here, this number 765 degrees. See this number. This is more than 360 degrees. Isn't it, my children, or not? Yes. Now, in this case, remember these 2 points. Remember these 2 points. What is that? We know that the values of sin x repeats after an interval of 2 pi or 360 degrees. After 360 degrees, sin values are lying between closed interval -1, 1. After 360 degrees, again sin values lies between -1 and 1 only. After every 360 degrees, the same value repeats. Understood this point, my children? So, if the angle is greater than 360 degrees or 2 pi, then first try to convert it in the multiple of 360 degrees or 2 pi. Make it simple and then solve. Understood this point, my children? So, these 2 points are useful for finding the value of sine 765 degrees. Okay, my children? Right. So, we can write this sine 765 degrees as sine 360 degrees into 2 or 2 into 360 degrees. What will get? 720 degrees plus 45 degrees. Understood this number, my children? Understood this part? I wrote 765 degrees as 2 into 360 degrees plus 45 degrees. Understood this part, my children? Right. So here we have written multiples of 360 degrees. So we can remove this part. We consider only this part only. So sine 45 degrees. We know sine 45 degrees value. What is the value of sine 45 degrees? Yes, 1 by root 2. Therefore, sine 765 degrees value is 1 by root 2. Understood, my dear children? Right. Now come to the question number 7. Find the value of cosecant of minus 1410 degrees. We have to find the value of cosecant of minus 1410 degrees. Okay, my dear children? If you observe this angle, it is a negative angle. If a negative angle is given, immediately we have to use cos of sine of minus x is equal to minus sine x. I gave the concept. We have discussed that point previously. So we can write cos of minus x is equal to minus cosecant of minus x is equal to minus cosecant of x, because cosecant of minus x is equal to minus cosecant x. We used this property. We used this identity. Okay, my children? Right. This is equal to minus cosecant of, see here, this number converted into positive number. Now we have to write as a multiple of 360 degrees. So we can write this number as 4 into 360 degrees minus 30 degrees. Divide this number, okay, by 360 degrees. Then we get like this only. Okay, but children, understood this step? Right. Minus cosecant of, I told you clearly previously, we had to remove this part. Then what is left here? Minus 30 degrees. Minus 30 degrees. Understood this part, my children? You have to remove the first term. You have to write only, you have to consider only second term. What is the second term here? Minus 30 degrees. So we wrote minus 30 degrees only. Understood this step, my children? Right. Again, it is in the form of cosecant of minus x. What we will get? Minus cosecant x. Previously we have used that formula in this question itself. So minus of minus, what we will get here? Plus. So cosecant of 30 degrees. Cosecant of 30 degrees. Same formula, because cosecant of minus x is equal to minus cosecant x. Understood this part, my children? Understood this step? Right. Now, what is the value of cosecant 30 degrees? Yes, it is the reciprocal of sine 30 degrees. So, 2. Understood, my children? Right. Therefore, cosecant of minus 1410 degrees is equal to 2. Understood, my children? Right. Now come to the question number 8. Question number 8. Find the value of tan 19 pi by 3. We have to find the value of tan 19 pi by 3. If you observe this angle, it is given in the radian measure. Okay, my dear children, in the previous questions, the angles are given in the degree measure, whereas here the angle is given in the radian measure. Okay, my dear children, right. Now come to the solution part. Tan 19 pi by 3. Now see here, what is the denominator? 3. So we have to write this numerator, divide this numerator, okay, by the denominator. Then what will you get here? Tan 3 6 are 18. Isn't it or not, my dear children? So 6 pi plus pi, 18 pi plus pi by 3. We have to split this number as a multiple of 3. 3 6 are 18. So 18 pi plus pi by 3. I wrote numerator like this. Understood this part, my children? Numerator part. Right. Now we split into two fractions. We split this into two fractions. Okay, my children? Right. This is equal to, if we are splitting that number into two fractions, what we will get? 18 pi by 3 plus pi by 3. Understood, my children? We have splitted into two fractions. Then we get like this. Understood this part, my children? Right. This is equal to tan of 3 1s are 3 6 are. That means 6 pi plus pi by 3. Understood this part, my children? 3 1s are 3 6 are. So 6 pi. We get first term as 6 pi plus the second term is pi by 3. If you observe, this is a multiple of 2 pi. It is a multiple of 2 pi. Same as 2 pi is nothing but 360 degrees. So we can remove this first term. We can consider only the second term. Understood this part, my children? That is equal to tan of pi by 3. Tan of pi by 3. What is the value of tan pi by 3? Yes, root 3. Because tan pi by 3 is equal to root 3. Understood, my children? Right. Now come to the question number 9. Question number 9. Find the value of sine of minus 11 pi by 3. Understood this question, my children? Right. Sine of minus 11 pi by 3. If we observe this angle, it is a negative angle. If negative angle is given, we have to use sine of minus theta is equal to minus sine theta. So what will you get here? Minus sine 11 pi by 3, because sine of minus theta is equal to minus sine theta. We used this step to get this step. We used this property. We used this formula to get this step. Understood this step, my children? Right. This is equal to minus sine of, previously what I told you, what is the denominator here? 3. So we had to split, we had to write this number as a multiple of 3 and some number. We have to use multiple of 3 minus some number. We can write like that also. So I am writing 3 4s are 12. Okay, so I am writing here 11 pi as 12 pi minus pi by 3, because 12 is a multiple of 3. That is why I wrote 12 pi minus pi. We can write 9 pi plus 2 pi also. Both are correct. We can follow that also. Understood this part, my children? Right. This is equal to minus sine of, I am splitting into two fractions, that is 12 pi by 3 minus pi by 3. Okay, my children? Right. Understood this step, my children? Right. Minus sine of, what will you get? 3 1s are 3 4s are, so 4 pi. Understood this first term, my children? Minus pi by 3. I wrote the second term as it is. Understood this part, my children? Right. Minus sine of, if we observe first term, it is a multiple of 2 pi. It is a multiple of 2 pi. So we can remove that first term. We have to consider only second term. That is, what is the second term here? Minus pi by 3. Understood this part, my children? Understood this step? Right. So again here, sine of minus theta value, we use the formula. So minus of minus, what will you get here? Plus. So sine pi by 3. Finally we get sine pi by 3, because sine of minus theta is equal to minus sine theta. Again we use the same formula. Understood this step, my children? Right. What is the value of sine pi by 3? Yes, root 3 by 2. Therefore sine of minus 11 pi by 3 is equal to root 3 by 2. Understood, my children? Right. Now come to the exercise 3.3 concepts. Exercise 3.3 concepts. In this exercise we discuss trigonometric functions of sum and difference of two angles. Means sine of a plus b, sine of a minus b, sum or difference of two angles. See this first one. Here I am writing all the formulas which are useful for exercise 3.3. Not only for exercise 3.3, in future also these formulas are very very important. Where, okay, my children, memorize these formulas well. Okay, first one, sine of x plus y. Sine of x plus y is equal to sin x cos y plus cos x sin y. I repeat this formula, sine of x plus y is equal to sin x cos y plus cos x sin y. Okay, my children. Now come to the second one, sine of x minus y. Sine of x minus y is equal to sin x cos y, sin x cos y minus cos x sin y. Okay, my children. In this formula, if you have remembered this formula, you can write this formula also, because in the place of plus y, if you write minus y, automatically you get this formula. Okay my dear children, right. See, cos of x plus y, cos of x plus y is equal to cos x cos y minus sin x sin y. I repeat this formula. Remember these formulas well my dear children. Cos of x plus y is equal to cos x cos y minus sin x sin y. Okay my dear children, if you remember this formula, you can write this next formula, that is cos of x minus y. In this formula, if you write minus y in the place of plus y, we get this formula. Okay my dear children, cos of x minus y is equal to cos x cos y plus sin x sin y. Okay my dear children, right. Now tan of x plus y, tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. I repeat this formula my dear children, listen well. Tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. Okay my dear children, right. Now next formula, if you remember this formula, automatically you can write this formula by replacing y by minus y. Okay my dear children, so tan of x minus y, tan of x minus y is equal to tan x minus tan y by 1 plus tan x tan y. I repeat this formula my dear children, listen carefully. Tan of x minus y is equal to tan x minus tan y whole divided by 1 plus tan x tan y. Okay my dear children, now come to cot of x plus y. Cot of x plus y is equal to cot x cot y minus 1 whole divided by cot y plus cot x. I repeat this formula my dear children, listen carefully. Cot of x plus y is equal to cot x cot y minus 1 whole divided by cot y plus cot x. Okay my dear children, if you remember this formula, you can write the next formula, that is cot of x minus y. Cot of x minus y, cot x into cot y, cot x into cot y plus 1 whole divided by cot y minus cot x. I repeat this formula one more time my dear children, listen carefully. Cot of x minus y is equal to cot x cot y plus 1 whole divided by cot y minus cot x. Okay my dear children, these are all said to be trigonometric ratios of sum or difference of two angles. Now come to the next point, multiple angles. What are called multiple angles? The angles 2a, 3a, 4a, etc. are called the multiple angles. Okay my dear children, understood this definition? The angles 2a, 3a, 4a, etc. are called multiple angles, right. Now for these multiple angles, we are writing trigonometric functions. Okay my dear children, see the first one, sin 2a. Sin 2a is equal to 2 sin a cos a, that is equal to 2 tan a by 1 plus tan square a. Two formulas are there. According to the question, we use this formula or this formula. Remember these formulas well my dear children. Now come to cos 2a. Cos 2a is equal to cos square a minus sin square a. Cos square a minus sin square a, this is one formula. Otherwise 1 minus 2 sin square a, 1 minus 2 sin square a, this is another formula. From this formula itself we can derive these formulas. Similarly, you know sin of x plus y, sin of a plus b. In that formula, replace b by a, then you get this formula. Similarly here also, in that formula, the trigonometric functions of sum of two angles, in that formula, in the place of b, take a again, then you get these formulas. Okay my dear children, cos square a minus sin square a. Another formula, 1 minus 2 sin square a. From this formula we can derive this formula, that is equal to 2 cos square a minus 1. This is also another formula for cos 2a, that is equal to 1 minus tan square a by 1 plus tan square a. So totally there are 4 formulas for cos 2a. Okay my dear children, remember all these 4 formulas. According to the question, we use any one of these 4 formulae. Okay my dear children, right. Now come to the next formula, tan 2a. tan 2a is equal to 2 tan a by 1 plus 1 minus tan square a. Tan 2a is equal to 2 tan a by 1 minus tan square a. Remember all these formulas well, my dear children, which are very useful for the next exercise. Okay, my dear children. Now come to sin 3a. Sin 3a is equal to 3 sin a minus 4 sin cube a. Sin 3a is equal to 3 sin a minus 4 sin cube a. Now come to the next formula, cos 3a. Cos 3a is equal to 4 cos cube a minus 3 cos a. Okay, my dear children. Understood? Right. Now last, tan 3a is equal to 3 tan a minus tan cube a by 1 minus 3 tan square a. Tan 3a is equal to 3 tan a minus tan cube a by 1 minus 3 tan square a. Remember all these formulas well, my dear children. Okay, right. Now come to this point, submultiple angles. What is meant by submultiple angles? The angles a by 2, a by 3, a by 4, etc. are called submultiple angles. Understood this definition, my dear children? Submultiple angles means the angles a by 2, a by 3, a by 4, etc. are called submultiple angles. In our course of study, in general, we use this submultiple angle only, not a by 3 or a by 4, etc. We stop by a by 2 only. Okay, my dear children? Right. Now, first formula, sin a is equal to 2 sin a by 2 cos a by 2. From the multiple angles formula, we are deriving all these formulas. In the place of 2a, we are writing a. Then we get this formula. Understood, my dear children? Right. That is equal to 2 tan a by 2 by 1 plus tan square a by 2. 2 tan a by 2 by 1 plus tan square a by 2. Okay, my dear children? Right. Now come to cos a. We have learnt there are 4 formulas for multiple angles. Here also we write 4 formulas for submultiple angles. Cos square a by 2 minus sin square a by 2. Cos a is equal to cos square a by 2 minus sin square a by 2. That is equal to 1 minus 2 sin square a by 2. That is equal to 2 cos square a by 2 minus 1. That is equal to 1 minus tan square a by 2 by 1 plus tan square a by 2. All these formulas are derived from multiple angles only. Replacing the 2a by a, then we get all these formulas. Okay, my children? Similarly, tan a is equal to 2 tan a by 2 by 1 minus tan square a by 2. Okay, my children? Right. See, these are also very useful formulae. These are also derived from multiple angles. 1 plus cos 2a is equal to 2 cos square a. 1 minus cos 2a is equal to 2 sin square a. These two are also derived from multiple angles formulae. Okay, my children? Right. Now we are going to learn about transformations. These are all these eight formulas are called transformations. These are formulas. See here, sin c plus sin d. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. Next formula, sin c minus sin d. Sin c minus sin d is equal to 2 cos c plus d by 2 sin c minus d by 2. I repeat this formula, my dear children, listen carefully. Sin c minus sin d is equal to 2 cos c plus d by 2 sin c minus d by 2. Now third formula, cos c plus cos d. Cos c plus cos d is equal to 2 cos c plus d by 2 cos c minus d by 2. I repeat this formula. Remember these formulas well, my dear children. Cos c plus cos d is equal to 2 cos c plus d by 2 cos c minus d by 2. Okay, my dear children? Right. Now come to this formula, cos c minus cos d. Cos c minus cos d is equal to minus 2 sin c plus d by 2 sin c minus d by 2. I repeat this formula. Listen carefully, my dear children. Cos c minus cos d is equal to minus 2 sin c plus d by 2 sin c minus d by 2. Otherwise, if we are taking minus common, we can write this formula like this. 2 sin c plus d by 2 sin d minus c by 2, not c minus d. See this difference, my children. Here c minus d by 2, here we wrote as d minus c by 2 and we removed negative sign here. Understood this formula, my children? Right. Now come to this formula. 2 sin a cos b, 2 sin a cos b, 2 sin a cos b is equal to 2 sin a cos b is equal to sin of a plus b, sin of a plus b plus sin of a minus b. Sin of a plus b plus sin of a minus b is equal to 2 sin a cos b. Now come to this formula. 2 cos a sin b, 2 cos a sin b is equal to sin of a plus b minus sin of a minus b. Sin of a plus b minus sin of a minus b is equal to 2 cos a sin b. Okay, my children. Now come to this formula. 2 cos a cos b, 2 cos a cos b is equal to cos of a plus b plus cos of a minus b. 2 cos a cos b is equal to cos of a plus b plus cos of a minus b. Okay, my children. Now minus 2 sin a sin b is equal to cos of a plus b minus cos of a minus b. Cos of a plus b minus cos of a minus b is equal to minus 2 sin a sin b. Okay, my children? Right. Or 2 sin a sin b, 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. I repeat this formula, my children. Listen carefully. 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. All these formulas are very useful, my children, not only for this exercise, for the competitive exams also. Okay, my children, memorize these formulae well. Okay, my children? Right.